Oh, it is. It is here.
I'm just going to say their opposites because
I'm not sure if I said that wrong or what. Like, you could write this. But
that's the one.
oh, okay.
Oh my gosh. We were like back there.
That's easy.
Yeah, it's so much easier.
Get it from we have a rabbit, and then
Did you all complete your sheet completely?
yeah.
Yeah? Are you done talking to your partner?
Yeah.
Okay, so now you can face back forward, you can turn your desk, and we're going to continue to the knowledge check. Do you all have any questions on the sheet? Yes? Do you have questions? No. Does anyone other than George have questions? Yes, no, maybe, sometimes?
Nah.
So for your knowledge check, you do not need a piece of paper. You just need your hands and your brain. Great. Are you ready? Yes, please. So for your knowledge check, we're just going to recap one more time. Inverses, so functions, and one-to-one functions. Okay? Okay. All you need is your hands and your brain. Is everybody ready? Yes. Okay. So, if it is a function, it has an inverse. Is this statement sometimes true, always true, or never true? So for sometimes true, you can hold up a number 1. For always true, you can hold up a number 2. Or for never true, you can hold up a number 3. I see all ones. Does everyone agree?
Yeah.
All right. Yes, sometimes true. So, in the first example, you just have a simple function here, and it does have an inverse. But the second function, it doesn't have an inverse. Okay? Now on to the next. Only one composition needs to equal x to be an inverse. Sometimes true, always true, or never true. I see some never truths and some always truths. 5 more seconds. That's still 3. I see never true. Let's see what the answer is. Never! Both of them have to equal x or it is not a thing. All right? All right. One-to-one functions will pass the vertical line test and the horizontal line test. Sometimes true, always true, or never true. So if you need help, remember back to your ACR today. Okay, let's see. Always true. Look at that. Good job, everybody. I do. A parabola has an inverse. Sometimes true, always true, or never true.
Oh, yeah.
So, George, why do you say always true?
Because doing like this, like if it's going this way, it's gonna look this go like this. Yeah.
Darren wants to answer as well. Thank you, George.
A parabola, so let's just say an example parabola would be y equal x squared, right? To find the inverse of x squared, you just square x. We got it?
Would you square x?
Not square x, the inverse of x squared would be square root of x. And then if you solve it, you get inverse.
Square root of x, square root of y.
What?
Square root of
I'm
x.
sorry.
So y equals x squared, right? So then square root of y.
No, you have to switch them now. You have to put x equal to y squared and then you solve.
Yeah, so you'll put x is equal to y squared, then you will solve. And then what would you get? So let's see. No, sometimes true. So the parabola example was a very good example, but you can use a parabola with a restricted domain and it would become a one-to-one function with an inverse. That's cheating.
It doesn't have inverse, but it's you part of it.
Yes, and that's also seen in the first number 4 in the packet that we gave you today, where the tables were. Yes. Okay. And that's the end of class. So make sure you come pick up this peak paper. Keep your inverse sheets off from today because you can use those on your Alex Tonight for homework when you start to complete your 3 topics. Have a good day, everybody. Thank you, Ashley. Don't forget any of your belongings.
Oh, yes, it is. So because that's positive and that's positive. Oh wait, you might be able to plus one?
Scale. Scale graphs. 1, 2, 4, 6, 8, 5, 10. No, you didn't scale the axis. You're always going to show your intervals. You have to say this is like 1, 2, 3, 1, 2, 3, 4, 5, 10, 15. I mean, it's right. It's one of the common mistakes made is graphing scale graphs. And if I actually gave you a graph without a scale and asked you to name this point, you can't. It's meaningless. The whole thing's meaningless.
Really? Oh, yeah.
Yeah, 60%, which is a lot better than I thought I did.
Is all of GC?
Yes, JCPenney is going out of
No.
No, these stores in Ohio. So
Oh.
for this announcement,
That's
I
bullshit.
was in South Euclid, so the one in Richmond Heights is going out of business if you look guys on the east side. You know, go to JCPenney and get you some nice business quotes for your resumes. You know, like when you get an interview, the resume is just a paper, but you also have to look good and presentable. You know, so go get you some slacks, find a suit if you can. Ladies, get you a skirt suit, some nice shoes, some stockings, you know, something nice. Go to JCPenney, you know. So I included this picture here. I saw a beautiful sunset on Friday, and I just wanted to share this all with you. I went to Cincinnati for the weekend for an LSAM conference in Cleveland State, and I enjoyed myself, and I just wanted to share a part with you. LSAM conference. Will Stokes Alliance for Minority Participation Scholars. So basically, if you're a minority student, there are scholarships and research opportunities for you all if you're interested.
So those are announcements and reminders. So we have a lot of topics for chapter 5, 42 of them. So if you start today and you do about 3 topics a day, you should be in good shape by the 50% point and by the end of the due date. All right? Can you handle 3 a day? No.
Yes, you can.
I think you
So
can.
like, maybe not 3 every single day, but if you do like 1 or 2 today, then you can tackle another one tomorrow. Or if you have a nice block of time, like 2 hours in the middle of your school day, you can go to the NLC, you can come to our office, or you can find a computer lab on campus just to sit and knock out, 18 problems, which is not really that much.
I mean, it makes sense because we do, 3 or 4 topics every day.
Yeah.
And then go home and do those while they're fresh in your mind. And then
Except none of the topics that we're going over are actually the first ones.
Yes, they are. You can find them.
Move around and you can find them. Drop down there.
Yes. Everyone knows how to navigate Alex, right? No.
Literally, all I know is
So, yes.
Are you sure some of them aren't locked?
Some of them may be locked, but the ones that you learn first in class are already unlocked for you to go through.
But there are some that you do have some prerequisite knowledge for, and those are the big lots.
Those are the ones that we might not have gone over yet. Okay. Oh, but navigating Alex, just an FYI, when you go in, once you first log into Alex, you're going to be automatically spit into the learn window or whatever. And then in the drop-down bar where it lists all of your topics, you can see the topics that you could do, which are the ones that do not have a lock symbol on them. Go ahead and read those topic names, and then they'll coincide directly with what the lecture and the SPT session have for you every day.
All right, can I expect anybody in office hours this week? Tomorrow, from 12:30 to 1:30? Does anybody want to come by and do 3 problems with me?
I'm not free to,
No. Okay, well then, yeah, you can make the appointment. That's part time here. Office hours made by appointment. So let any of us know, and we'll help you out with that. All right. And then our activities for today are an ACR. The HTC update is kind of bad today, but we just started chapter 5, so it's okay. And then the activity is think, pair, share, and then we have a knowledge check for you.
Is everybody ready? Woo! No? Yes! Today's great. So I pass out this sheet to everyone. Does people not have this? Does anyone not have this? No.
Really?
Yeah.
Sometimes Graham wants to say something.
Yeah, well, she's passing out that.
Yeah.
A note on grading on the test. There was one place where you had to make a composite function, and some of you got that wrong. Then you were asked to find the domain of that composite function. So any place on your grading where I write okay, okay means it's a wrong answer, but it's a right answer for your wrong answer. Do you follow what I'm saying? I'm not going to ding you twice. So if you got the composite function wrong, I graded your domain based on what you had the composite function to be. The other place that I used okay that I wasn't really happy about, but we didn't probably talk about that, and I don't know how much they did it in Alex. They asked about vertical and horizontal asymptotes. They wanted the equations, not just what they were. They wanted the equations. So let's say this is my vertical asymptote. This is my vertical asymptote. What's the equation for this? so why is nobody telling me? First of all, it's not scaled, so you have no idea where that is. That's the other place that I took off on lots of your graphs, when you didn't scale your axes. Now, if you labeled points and stuff, I could work your points back to a scale, but you have to scale axes. All right, so this is meaningless without a scale. So let me just do this. This is 1, this is 2. So now can you give me, what does every point on this line have in common?
X equals 2.
X equals 2, right? And this is what it was looking for. Some of you are writing your vertical asymptote equals 2, and I wasn't taken off on that, but I would have to on the final, because I'm now telling you. It's, the vertical asymptote is the name of something. It's not a variable. A name cannot equal 2, right? So it should be X equals 2, and then horizontal asymptote should have, what does every point on this have in common? They all have the same Y values. So this would be Y is equal to -3. This would be a horizontal asymptote. It's not H8 equals -3, okay? So any place I wrote okay and didn't take off points, it means I'm not entirely happy with the answer, but I didn't take off points. So you not only want to look to see where you missed points, but look for any place I wrote okay and try to figure out, and if you can't, you need to ask me, okay? All right, go ahead.
All right, so here's the homework completion for chapter 5. So we only have 9% done.
But that's okay, because we just started, and remember?
You're right,
Yes.
it is.
And you have
especially after a
10 days.
test.
Yes, you have 10 days until 50% completion, so make sure you learn about 3 topics a day.
So if you do 3 every day for 10 days,
And then
how
I
many
have
have
to
done?
assume
Good.
that I switch down here.
Okay, great job.
It's
We're being section 2, so good job, we're back on top. That's
all-
great. Come on, class.
So, right, but I don't know which one of these.
Out of the knowledge topics, that means that those are topics you don't have to do.
You have to do all of the topics.
But it says 15 of them already done.
Oh, so you've already completed 15 of
No.
them?
Like when you start a chapter, it's like pretty constant. Some are like down.
So remember that initial knowledge check that we took?
Yeah.
So apparently, according to that test, you already know those topics.
Oh, so you just skip those.
So that's like a baseline test. It's not so much you skip them, but you already.
You already know. Did I answer?
Exactly, that's all it takes, then just put one here and one there, we're good to go.
Alright,
That's all you need.
Yeah, so there's that, and then here's the teams. My team, you really got to put the gym here. Like, let's go. We only have 4%.
Look at us, look at
But
us.
Saida, she's killing it.
She's not killing it.
They are still, yeah.
Okay, well, Saida's team, good job. Me and Karan will fight the rest of us. And then here's the individual teams. My team 1 and 3. All right. Yeah. Ooh, that's something else. You gotta work to get 1%. Okay.
Thank you all for
All right.
completing your homework and completing your homework throughout the next few weeks. Now we can move into our ACR. So I passed out these graphs for you all. And you can write on the back of these. Don't write on the graph just yet. You can write on the back or a blank piece of paper first. Can everyone hear me? Can everybody hear me? Yes. Thank you. Okay. So, this is not a race, but this is an overview. So, what it determines a function, if it passes the vertical line test. What determines a one-to-one function, if it passes the vertical line test and the horizontal line test. So the following slides that we go through will be determining whether something is a function and if it's a one-to-one function, okay?
So what's the paper for?
You'll see. So you can write on the back of the paper if you want to answer, and then the front of the paper, though, keep that until the end because you're going to turn it in. Okay, so for the first one, this is a function. Yes, why is it a function? Okay, is this a one-to-one function?
Yes.
Why? Great, look at that, you guys are right. See you again. Okay, next, is this a function?
Yes.
Yes. Is it a one-to-one function?
No.
Good. Okay, is this a function?
Yes.
Is it a one-to-one function?
No.
Cool. You guys know this stuff. This is great. Okay, is this a function?
Yes.
Okay. Is it a one-to-one function?
No.
Okay. Since you guys know. Okay, this is a function?
Yes.
Okay, is it a one-to-one function?
Yes.
Okay. Yeah. Oh, okay, this is a nice one. So this is just a section of a signed graph, just so you guys know. Okay. And you can change all things about a function if you restrict the domain, which is what you all have been learning these past few weeks. Now you can try. Okay. Now draw the graph of a function that is not one-to-one. So that's what the graphs are for on the front of your paper. So on one of them, you would graph a function that is not one-to-one. Just draw the graph. You don't have to do it.
You get brownie points if you know the equation.
Yeah.
Yeah, what does that get?
A pat on the back.
Yeah. The satisfaction. Does anybody want to volunteer or do I have to pick?
I'll pick. Ooh. This is difficult. Ooh, Shelby's looking at me. I'll pick her. If you want. And make sure you draw a function that is one-to-one as well on the other graph. Okay. That's Dr. Smith's name. You're welcome. Can everyone see her graphs? Okay, so can you explain why the first one is not one-to-one?
Because it doesn't pass, and the second one.
Okay, thank you. Now, I put you all in groups, well, not groups, pairs. So like Shelby and Hassan are pairs, Anthony and Dwight are pairs, Kirk and Steven are pairs. So everybody in the back of the row turn inside, and that person is your pair, okay? So you two are pairs, I'll find you another pair. You two are pairs, turn inside. Yeah. And if you don't have a pair, you can find a pair, find a friend. Everybody gets a paper.
Is each person going to?
Every person should have a sheet. We should have enough for everyone to have a sheet. So directions for this activity. The first thing that you're going to do once you get your sheet is start to answer as many questions as you can. And then after about 3 minutes after answering one of your favorite questions or as many as you can, you're going to turn to your partner that you're sitting with and you're going to go over the questions that you have completed or that you need help with. And then after a few minutes, we're going to call out one of the pairs to explain whatever problem you all work on. So you can jump around the sheet, but it's nice to go in order because they all coincide with each other. So you can begin now. Make sure you're facing your pair.
Last call for homework from last week. That was the purple sheet.
Yeah, right.
your path and follow each question.
Number 2 is just passes the sentence break.
How about you on this here?
Okay, now it's time to share with the whole class. So everyone's attention up here, please. Thank you. Okay, so Fanny and Ariel are going to share number 1 and number 2 with you all.
For the first one, the two-line questions like are inverse of one another. Describe the relationship that exists between their coordinates. You put that the x turns into y in this function.
Yeah. So basically, each coordinate shares the same numbers for your inverse functions, but they're just flipped in the second function. Yeah?
And then number 2 was a function that has an inverse is known as a one-to-one function. How does your answer to question 1 relate to a function being one-to-one? So if I had like the regular functions x and the inverse functions y, they're equal to each other, so it would be one-to-one.
That was Ariel and Fanny. Thank you. Now you can resume your paper. And we're back on the thinking part, so you do it individually right now, and then in a few moments you'll hear the air horns and you'll share with your partner.
Yeah, okay, that doesn't guarantee that it's one to one.
So it's showing like, you know how they're in
So putting that in verifies it, isn't it? Well, if there was an application, all the ones we have to wait till the yes, to technically, you have to make sure that the original function is this versus the original outcome. Okay, so here, so what is G of X?
and then this is where you
What's G of X? It's this, right? So, then you place G of X, which is 1/2. Next, you see you lost your X.
So,
That's why you got one. It should be a 1X. No.
domain
it's-
is all
it's-
the X and Y, right?
Oh, all right.
So,
Did you see you lost your X there? Right, so now we're supposed to take
So,
the F function and put it to the G function, which is this one, right?
Oh, the
So we
drive
take 1/2 and place
yeah,
it as
so,
the
what's
line. Right. Minus 3. You lost your X there. You see that?
okay, so go from 2 all the way to each other both times. Well, that's just on the graph here, but it doesn't keep continuing on. So it's gonna
the dotted line.
yeah. Well, you can't really, you just make it, you just have to state them separate. Well, it looks like it's, so the range is the y net, right? That's our academic. So where's this from?
This is like a dream team.
A little bit below. Yeah. And now I have one more question. So you see where the rows start here? Are those values
Can you count?
or not? So that means we have not parentheses correct. Can I get everybody's attention? Let's see, so we're gonna go for 3 right now, and I'm going to pick George and Michael. Oh, you guys did number 3?
Yeah, we did number 3.
Never mind, we need to do number 4.
Okay.
Can you guys do number 4 for me?
Only
So-
4?
Yeah.
Okay.
Yeah. So let's do it.
The first page, question 3 for show of hands, did everyone complete the first page? Yeah.
Do this problem.
Okay.
So I just did a
Right. So just come.
Four is hard.
Here.
On the first page. You guys have-
Yeah. Yeah, so
So can we all direct our attention to Jack and Victoria? They're going to explain number 3 to you all.
Okay, so basically this is the graph that we had. This one's F, this one's G, we decided, and you just point the slope form to find the slope, and then you can find your intercepts just by looking at the graphs.
Did everyone get the same equations? Yes, great. Now we're going to move to number 4. Thank you, Victoria and Jack, for coming to the board. Now we're going to move to number 4 with George and Michael.
Alright, so given these equations and stuff, we start off with 2x plus 6, and then 1/2 x minus 3. So basically, I said f of g and stuff.
Can everyone hear and see what George is doing? Okay.
Okay, so let me I'll draw out what I did exactly. So I just distributed these together, and basically I got 2 over 2x over 6. So that's 6. And then basically this is just going to be a 1, and then I have this, and then I can just cross this out, and then I'm left with an x.
So you cross it out because of what?
Because it's just a 1. Right. 2 over 2 would be 1. 2 over 2 is 1.
It's 1, and then negative 6 plus 6 is what?
0.
Great. So then you're just left with the variable x.
Yeah.
So that's the point of all of your inverse functions. Once you compose them, you should always get the variable that you're trying to find, which is x. Okay? Can you just explain it?
I just put f into g at 1/2 parentheses. This is f 2x plus 6, and then I close that and I put the rest of g, which is minus 3. And I just distribute it in, and that's the answer.
So he also got x. So once you get x as your variable at the end of you composing your functions, you know that you have taken the right path to find your one-to-one function. Okay, now you all can return to your paper and continue. Thank you. Thank you, George and Michael.
That's how this contest is. It's fine as a mirror.
Well, I would say because it never actually goes down. It looks like it's like right there.
Does that make sense?
I know, so I can't assume that it is before and not included, so it's not. Technically speaking, I can't actually say that.
Our mirror images onto my white board.
I was just saying, I mean, I know that's where it was from, and I'm not percent sure that that is included, but. Oh, did you? Yeah.
So at this time, everyone should be sharing with their partner their answers so far.
Oh, thank God. Hey, Ryan.
I think it may. Oh, yeah, I got that.
Yeah, you can.
First of all, sometimes I put that out. Then you put it every color.
Yeah, but I can't. Yeah, and then from there.
From your. So this is one function. So you can't have a substitute yeah.
It has to pass.
Because it has, because you can't have a point in the school. Yeah. And then you can't actually have any negatives come out. So as long as you have positive. Yeah. Yes, I understand.
This one right here. Yeah. This is long.
So therefore, you can plug it in.
I think I'm going pretty far through it.
Yeah.
Where's she at?
All right, can I have everybody's attention up here, please? Thank you. So we have Talia and Weston up here, and they're going to go over question, what was that? 1, 2, and 3 on the second page for you guys, okay?
Oh, wait, do we do 5 for the Y1 or Y2?
We'll go back to that. All right, but here's 1, 2, and 3 on the second page.
All right, so the range of f is 2 to infinity. I mean, the domain is 2 to infinity, and the range is -1 to infinity.
Can we have everybody looking up here, please?
And then for number 2, the domain is -1 to infinity, then the range is 2 to infinity.
Can everyone hear her? No? Can you repeat that one more time?
All of this is me. It's me? Oh, okay, okay.
Yeah.
Hello?
The domain for number 2 is -1 to infinity, and then the range is 2 to infinity. So, yeah. And then for number 3, describe the relationship between the domains and ranges of these inverse functions. Basically said that the domain of f is the range for g. So, okay, explanation. Thank you.
Talia and Ruslan. Thank you. Can I have a volunteer for number 4 that would like to just explain from their seat? Yes, Dewad and Anthony.
Yeah.
Yes.
Okay, so we just chose 3 random values for x for the first one. We had
Your turn.
Alright, so for the
So they're on page 2, and they're on the first number 4 of page 2. Okay.
yes. Wait, is it working both yes? Okay.
No, don't press it again.
What?
Press it once.
Okay. So for the first value, we had -6 and 7. For the second, we had -2 and 1. And then for this last one, it's 2 and -1. And then for the next one, we had -1, 2, and then 1, 6, and 7, 10.
Does anybody disagree?
So what did you see in your x and y values of both of your functions? Did they directly match each other?
Yeah, they're opposites. They eventually become opposites.
And where do you see that?
Towards the end. Well, for the first one, yeah, towards the end.
What is the end?
-2, 1, and then 2,
-2, you got 1.
Yeah.
And then,
Why are you pressuring me right now?
so for that part of your question, you're supposed to choose points that were visible on your graph.
Yeah, that's what we did.
So you chose -2 for an x value,
Yeah, that's for F.
but -2 has to be visible for both of your,
It shows 2, not me.
you just said -2. Okay, so for 2, for your first function, you got -1.
Yeah.
And then for 2, for your second function, what did you get?
Yeah, if you look.
That wasn't made clear.
I'm sorry. It did?
So,
Yeah, it says use your answers as the X value.
Yeah,
So
it's
you
right.
use
Okay.
The y value from the first function is
Yeah.
to be used as the x value.
Okay.
It's good.
Okay. Sorry for that discrepancy. You can return to your paper now. Thank you.
Like,
It's just shit time. You know what? I haven't done it. I tried it. It's probably not. So why is
You have to plug in and you have to plug G in.
It's just confirm on the
Like, hey, man, where?
Okay.